Computer. Cool. Good morning, everybody. This is the November 10th edition of the Cluster API Provider Nested Office Hours. Today we have a short agenda. And before we get started, I think there's only one new person here. Shabik, would you want to introduce yourself?
Yeah.
Sorry to put you on
Hi,
the spot.
I'm Shabik. I work at Apple alongside Chris. I joined just a month ago. So I'm mostly just looking around, trying to figure out what's going on and see how I can best help.
Cool. And then the big agenda item today is Charles put in a PR this morning for the updated design doc. And so you're going to take it over. You should be able to screen share now.
Okay.
And just walk us through what you've come up with.
Okay, sure. Let me try to share screen. Could you see the proposal?
Yep.
Okay, great. So, so I'm going to go through the proposal I just submit. So in this proposal, we aim at come up with aim at define how we are going to use all this nested CR to create the actually components for the NCP. So before we start, I would like to explain some terms I'm going to use in this proposal. All these terms, we need some further discussion about, do we want to add these terms to the glossary, but these terms I'm just temporarily using these terms for this proposal. So first one is the supercluster, which is an underlying cluster that manages physical nodes. And the supercluster will run all the pods. And second one is the nested control plane. I will refer it as the NCP in the rest of this proposal. So this is a control plane that are hosted on a supercluster. And next one is the nested control plane templates, which contains all the information required to create the NCP. And I will refer it as the NCPT in the rest of this proposal. The next three are the nested CRs we are going to talk about. The first one is the nested etcd, which contains the etcd information that's required to create the nested etcd. And the next two are nested KAS, which is the nested API server, and the nested KCM, which is the nested controller manager. Both of them contain the information required to create the Kube API server and the Kube control manager for the NCP. And I also defined two new terms. The first one is subcontroller, which are the controllers in charge of each of the nested components, including the NETCD controller, NKAS controller, and the NKCM controller. And also the last one is the component provider, because sometimes user may want to use their own operators to create the components. So this one will be the component provider. And before we continue, I wanted to make sure we are on the same page. So how we are going to use all these CR and all these controller to create a nested controller plan. So there are two user-facing CR. The first one is NCP and the second one is NCPT. And the user are not supposed to create the nested etcd, AKS, and a KCM directly. So the standard process will be something like their standard process will be, first we'll create a nested control plan templates. And then a user can create a nested control plan NCP CR. And one NCP CR need to refer to an NCPT CR. And then the NCP controller will create the rest of the nested controller, and etcd, KS, and KCM. Then when all these nested CR are created, then the subcontroller will start to create the real components. So that's the basic idea of how this CR and the controller cooperate with each other. I will skip the summary and the motivation. And if you are interested, you can read later. The goal of this proposal is, first, we wanted to define the CRD that represent each nested component, which is the NETCD, KAS, and the KCM. And all this CRD need to meet two requirements. First one is they have to be portable. So the CRD should hold information that are required by different component providers. sometimes user may want to use etcd operator or etcd cluster operator to preserve their etcd components. So to this end, the CRD need to hold enough information for different component providers. The second requirement is the CRD need to be customizable. So we should allow user to customize each component of the NCP. For example, we should allow user to specify the image of the component, and also the component version, and also something like the command line options. For example, sometimes user may want to turn off some of the controller inside the controller manager. And second goal is we wanted to define a standard process of creating nested components for NCP, regardless what component provider are specified by the user. And also we will present two examples of creating NCP natively, which means we will create all the components on the cluster in memory as pods. And then the second one is second example, we will present how we can create the Kubernetes API server and KCM still natively, but we are going to use a third-party provider to create the NETCD components. So in this proposal, we are now going to talking about how NCP or NCPD controller are going, how NCP and NCPD controller works. And we are now going to discuss the details of how the third-party component provider work. Okay. So based on the comments from the last PR, I used to submit another PR, and based on the comments from last PR, the two main concerns are how we can make the CR portable and also easy to customize. So generally, when we creating the three major components of an NCP, we require some very similar high-level information, like what's in the components version, how many replicas we are going to have for each component, and the amount of computing resource required for each component. At the same time, end users also wanted to customize NCP components, like specify their own command line options. Therefore, we define a new struct named nested component spec, which contains common information required by different provider, as well as customized information specified by the end user. And each nested CR, nested etcd, KS, and KCM will have this nested common spec. So what's inside the nested common spec? First, we will have something like a common spec. Common spec define the version and the channel of this component. The version is something like 1.16 or 1.18. The channel is something like stable, release, or nightly. The second one is the resources, like how many CPU or memory you wanted to use to run these components. The third one is the replicas, number of replicas. Say if we are going to create the etcd natively, then we are going to use stateful set to create the etcd. Then we can specify how many instances we wanted to have inside the stateful set. And then the last field is the patch spec. Patch spec allow user to specify their own customized settings. We are going to borrow the common specs and the patch spec from the KubeBuilder declarative pattern, this project. So as we can see here, inside the common spec, we have the version and the channel. Inside the patch spec, we have the role extension. So that means user can specify whatever they want, valid YAML text or contents. So, and also if sometimes maybe the component provider, say if user specify wanted to use the etcd cluster operator, but the cluster operator does not allow user to specify some, to specify the settings of the etcd, then the patch spec will just be ignored. And yes, all nested CR need to contain the nested component spec.
Can I ask a quick question real quick?
Yes.
Yeah, sorry for interrupting. So within that regards, if somebody were to go through and say, try to use the etcd control cluster operator, for example, could we technically because of the implementation of this, are we expecting that, and you're probably going to get to this later, but are we expecting that if we were to go and build, say, for instance, an operator using the QBuilder declarative patterns setup, like the actual the QBuilder integration for it, could we make that so that the channels that are that the channels and the manifest that are built into that represent whatever operator actually implements it, and so that we could actually still support those fields? Would that actually work? Does that make sense, what I'm trying to get at?
Are you trying to say, can we put in something like maybe the provider information into these two fields?
No, no. No, I think so. What I'm trying to get at is like one of the things that's really interesting about the QBuilder declarative patterns project is how you get an actual how the manifests are configured. They're configured in the channels directory. Like I think it's channels/stable, and then you can have all of your releases underneath there as like nested directories. And what's interesting there is you basically have all of the raw YAML manifests to provision the control plane, or to provision whatever component is built on. So like if it's Core DNS, it's going to be the Core DNS deployment and the service, and all the RBAC for it is just raw manifest files on disk. Now, if we were to go and say we wanted to like hot swap these and say that etcd could be implemented by another operator, because of it just being nested etcd, we could just implement that nested etcd CR, but have the channels set up to be the actual files that are mounted locally could point to CRs creating other controllers, right? In essence, I believe that would work.
Okay, so my question is, what's the manifest you mentioned about the channel can be point to certain manifest? What's the manifest about? Is that something like YAML templates for the etcd, or I'm not sure I understand what's the manifest.
I'm guessing what Chris was mentioning is that if you, for example, if you want to a third-party etcd, so we just put that etcd CR in the channel. Is this what you meant? Is this what you mean?
In essence, yeah, in essence, because if you, I'm just going to drop a link into the main Slack. You can check it out after. But for all of those things, I just dropped the Core DNS implementation, for example, and it has underneath it has packages Core DNS, and then under packages Core DNS, it has 1.13, 1.67, and 1.70, which are like the available versions of that operator. And I think it would be the same for this. Like when we pack those manifests for the nested KAS, for example, it's going to be the deployment or the stateful set, the service we create, or the ingress we create, whatever the components are that we expose. Those would be just mounted in as files, already compiled in out of the box for like the default implementation, but you could always override them and mount a new directory in there, so that when we did an implementation that says use the etcd cluster operator, instead of using the deployment manifest, just mount in a new CR. And then behind the scenes, it should just be doing a kubectl apply. It does a little bit more magic than that, but in essence, a kubectl apply, which means whatever you supply in, I think this is, in essence, I think this is super supportive of what you're proposing here.
But
yeah.
The problem is so both Chao and I were discussing the channel, and we are not very sure what exactly the channel means. So things like what you're saying, that the channel is actually is a URL that point to the underlying raw manifest to deploy whatever pod kind of. We were thinking the same thing, because if you look at our proposal, we abstract everything. I mean, we abstract the pod spec into a few fields, so, right? So we still need to have a pod spec template somewhere. So we were thinking either we hard code it in the controller, because there are other fields in the pod spec, right? For all the components. Then another way you can think of is even in the common spec in the channel, we can point to whatever raw YAML file for this particular CR that, I mean, pod spec kind of thing we want to have. And you were saying that in that YAML file, we probably can do more, because if you want to introduce a third party, whatever CR, you just put in that raw template. And because we are do kind of could be applied anyway to, I mean, we will, based on this raw manifest, we will, finally build the YAML for all the parts or all the whatever object or we want to create to create the component anyway. So yeah, that may be okay, but our current proposal is kind of more straightforward. Is that we just tell exactly what provider do you want to have. We list all the providers that we support, and we will write interface code like exactly we did in the VC Manager. So for
Sure.
particular provider, we write an interface for it. I'm thinking this way is more kind of strict. I mean, there's no, I mean, in the channel way is kind of flexible. You put anything in that channel, we just apply it. It's debatable. Some people like this approach, like flexibility. But we currently, our thinking is because I don't think there are too many providers at this moment, maybe just one or two. Either
I'm not sure if the providers are what I'm worried about. I'm thinking more along the lines of like being able to heavily customize each component if you needed to, like just the flexibility to
yeah, the flexibility,
in essence, change whatever you want. But the using the declarative pattern stuff in essence is going to give us that, because you obviously have like the patch spec already.
Exactly.
You embedded the patch spec in there, so you can just patch any CR or any
exactly
deployment or any manifest that you put in there.
You know, patch spec is just we open the whole world. You know, you can do you can add anything. I mean, yeah. So since we already leave one, entry point for your customization, and you can do everything, and let's put the other part strict. That's my point.
Okay. Cool. All right. Continue. Sorry for interrupting.
Okay. It's okay. Yeah. Okay. And also I wanted to say something, because we think it can be different provider, they may want to use their own templates. So if we just specify some very general templates, we wanted to specify the templates, but maybe the etcd cluster operator, they don't want to use those templates, or it does not work with their scenarios. So I'm not sure if we should open up fields like the channel to allow user to specify a very highly customized YAML file or configurations. I'm not sure.
Gotcha.
Yeah, we can discuss it later. Okay. So we're now going to talk about how the NCPT or NCP controller are going to generate the nested common components back. But I think there will be a way. There will be an easier way, is to put in add 3 new fields inside the nested control plane template spec. So for each nested component. For example,
I don't think this is a proposal. This is just for the context of this particular proposal, for people to understand the workflow. In reality, Chris, you can come up with any design. Just have something like this. let people specify the CR and spec. That's it.
Yeah, that makes perfect sense.
Yeah, it's just to from my perspective, this one can be easier for me to like get all this information. Yeah, so first one, we will have something like nested etcd. This one will hold all the information required to create the etcd. Same for KAS and KCM. And we also allow user to specify the components a provider they wanted to use. So we define 3 new types. First one is KAS provider. Second one is etcd provider. The third one is KCM provider. And the following are some sample provider variables, constants. If user does not specify any providers, we are going to use they are going to use the native provider. We are going to implement the native providers for them. So the first one is the native KAS provider, and the second one is the native etcd provider, and also the native KCM provider. But the user can add their own add new providers like the etcd cluster operator or etcd operators. And same as before, we wanted to allow user to specify what provider they wanted to use. And I think if we can have something inside the nested control plane spec, then that can maybe easier for user to customize. So say something like we can add 3 fields inside a nested control plane spec. We can allow user to specify what etcd provider they wanted to use, what KAS or KCM provider they wanted to use. Okay, so let's go to the bootstrap process, how we are going to create the components. So before we start creating the real components, we need the NCP controller help us to prepare some resource. The first one is the cluster namespace. This namespace are going to store all the required informations for creating the NCP components, like the nested CR and some PKI config map. The second one is the NKAS service, because we are going to generate the certificates and the kubeconfig for the nested KAS. And when we generate the certificate and a kubeconfig, we need to have some IP address or whatever network address available. We need to bake this address into the certificates or the kubeconfig files. So we need to create this KAS service in advance. The third one is the nested CRs, and etcd, NKS, and KCM. That's all the three pre-request resource we need from the NCP controller. NCP controller can help us to create.
Do we need the actual Kubernetes API or the Kube API server service before we create the Kube API server?
I think so, because we need to generate the certificate. So when we generate the certificate, we need to put a valid IP address into the certificate.
I'm wondering if we could do if the Kube API server, or like the nested KAS controller, could create the service and certificates for, like, each individual component be responsible for its own certificate management. The same way that if we were to implement, if you were to push off from the native provider to, say, for instance, the etcd cluster operator, like that's going to go and handle its own PKI on its own. And so what if we did it so that each component contained all of the logic it needed for its own thing? So like, yeah. And so it created the service and created the PKI, and then there was like a shared set of labels that, not labels, a shared set of names for those resources for where it needed to sync between the two. So say, for instance, when the KCM gets kicked off and starts to try and hit the Kube API server, it grows and generates the certificates based on the CA that it knows about from the KAS resource.
Mm-hmm.
So that you don't have to do so much bootstrap, and everything is self-contained. Would that work? I don't know.
Yeah, I think we can. But at least we maybe need the NCP controller to generate the root CA files, maybe, because all is etcd, KAS, or KCM, etcd and KAS, they need to share the same CA files, right? Because all their certificate will be generated based on a same CA file. Okay.
I'm wondering if that would be a hard requirement. Because as long as you have access to, yeah, let's explore that. That you might be right there, and that might be something that we can set as like you can supply and override CA for the entire setup, so that if you already have one, for example, if we were to use like our standard root CA kind of thing, then we could just supply that in and then go from there.
But maybe but I think somehow in the document we better say, people think about they want flexibility. They want to have their own state manager for each individual component. But the problem is, if you use different root CA for different components, communication between them would be very complicated. Sure.
Right. Okay, cool. This is great. Yeah, keep going. Thank you so much.
Okay, so as there exist dependencies between components, like the API server cannot work without etcd, controller manager cannot work without KAS. So I think when creating NCP components, there may exist some orders, like we need to create the etcd first, then create the API server, then controller manager. And also when we're creating the API server, we need to know the IP address or a reachable network address of the etcd service. So that means the nested KAS CR need to be able to reach the nested etcd CR. Same for the nested KCM CR, because when you start a controller manager, you need to know where is the API server. So to this end, I think each nested component CR need to point back to the NCP CR. So, and after the nested CR reach the NCP CR, it can use the NCP CR to find out which other nested CR they wanted to visit. So I think we can add, maybe we can add something like the nested etcd object reference for each nested CR inside the nested control plane status. So after the nested control planes create all these CRs, they can add this, it can add the object reference inside the status. So it will make the nested control plane status look something like the following. Okay. And okay, so let's talk about how we are going to actually create the components. We allow user to specify the component provider in the NCP. And if user does not specify any component providers, then we are going to use a native way to create the NCP. And we are going to implement this native way as the default methods. So let's go to the figures. So here is how we are going to create this, how we are going to create an NCP components natively. So first, we will assume that there is a nested control plane template somewhere on cluster, and then the user create the nested control plane CR. The nested control plane controller notice that the NCP CR is created, then it start creating all the prerequisite resource, create the cluster namespace, and all the nested CR. And the first is the nested etcd CR. The nested etcd controller notice that nested etcd CR is created, then it start creating the actually etcd workload. So by default, we are going to use the stateful set to hold all this etcd instance. And after all this etcd instance are ready, then the nested etcd controller will mark the nested etcd CR as ready, and also store the certificates into a config map. We used to use, in last PR, we used the nested PKI CR, but as Chris suggests, maybe we just wanted to use this CR to pass around all the certificate and a kubeconfig. And I think if we do not have some logic, we do not have a controller for this CR, maybe we can just use a config map to make everything straightforward. Okay, so once the nested etcd CR is ready, then the nested KS controller will start creating the KS workload. So same as before, it will mark the nested KS CR as ready once all the KS instances are ready, and also store the certificates, the kubeconfig files into the PKI configuration. And finally, the nested KCM controller will start creating a KCM workload and mark the nested KCM CR as ready, store the certificates into the, it does not need to store the certificates. It does not have certificates for the KCM. It just need to read the PKI config map, to read the kubeconfig file of the KAS and use it to connect to the KS. And once the KCM is ready, the nested control plane controller can mark the nested control plane CR as ready. Then it can be ready for the end user to start using the NCP. Any questions so far? Okay.
That makes sense.
Okay, so sometimes that's a new part. That's a new things I just added in this proposal. So sometimes user may intend to use a third-party provider. So in this example, I'm going to assume that user wanted to use the etcd cluster operator to preserve the etcd components. So what's the process looks like? First, as before, the user are going to create an NCP CR. The NCP controller going to create all the prerequisite resource, the cluster namespace, and all the nested CR, the green one. Okay, and then the nested etcd controller. Nested etc controller notice that there is a new nested etcd CR, but this time the user wanted to use a third-party operator to create the etcd workloads. So the nested etcd controller will create an etcd cluster CR instead. Then the etcd cluster operator will do the heavy lift, will create the real etcd workloads, and it will mark the etcd cluster CRS stable once all these etcd instances are stable. Then same as before, as the native way, the nested etcd controller will mark the n etcd CRS ready and store all the certificates into the PKI config. So same as the native way, the KAS controller and the KCM controller will create the KAS and the KCM. And finally, the NCP controller will mark the nested control plan CRS ready. So, and this part, say if we wanted to support the, say user wanted to add a new provider mode, then it's the user's responsibility or the provider's responsibility to change the code of the nested etcd controller. Say, for example, here, if we wanted to use the etcd cluster operator, then the user need to add a code for creating the etcd cluster CR and watching the life cycle of the etcd cluster CR. Yeah. Any questions?
Nope, this is good. This makes sense so far.
Okay. So let's take a look at the definition of the nested CR, the CRD. First one is the nested etcd CRD. So inside the spec, we will have an object reference point back to the nested control plan. And then we will have the nested component spec, as I defined at the beginning of this proposal, hold the common information required by the etcd component and also some user-specified settings. Then we will also allow user to specify what provider they wanted to use to create the etcd. Inside the status, we wanted to add in a new field called provider object, because sometimes when you're using a third-party provider, then you may need to create a new CR to let the third-party provider start working. In a previous example, that is the etcd cluster CR. So this provider object will be used to refer to the third-party CR. And the same as the nested etcd CR, we are going to, in a KS, we have the same thing, the nested control plan, nested common spec, and a provider. And inside the status, we are going to have the provider object. And also for the KCM CRD, we are going to have the same fields. And yeah, that's all. That's all. Yeah. Any questions?
I don't think any questions, or at least not from me. I think this all makes sense. I have a couple things of feedback that I'll drop in on the PR. Things like potentially embedding the nested component spec instead of making that an attribute, just to make the API a little bit slimmer, so that common spec is at like the top level, like it is with most other cluster add-ons type projects. Yeah, I want to read through it a couple more times and give it a review, but I don't know about anybody else on the line. Wei, if you're talking, you're muted.
I just feel the second diagram you just presented using the third-party etcd kind of a cluster, a little bit not that nature, kind of a little bit complicated. I think the diagram looks like, and the implementation and explanation. So we probably can make it a little bit more straightforward somehow. I have no idea at this moment, but I also look at the etcd cluster operator. So we probably can draw some comments on that, see if we can simplify a little bit, make this diagram more straightforward.
Okay.
For example, we can have a load balancer just to create for our own CR, and that will be this decoupled with the whatever the etcd the cluster customer want to use, and use this load balancer to connect with them. And this way you can scale up, scale down the etcd without any kind of a reboot your API server, because your API server use the etcd client inside this API server. So without with all this etcd tightly coupled, you have specified all instance IP address in the API server YAML file. This will be a little bit not easy to change, and if we want to scale up the instance of the etcd. I will take a more look into this details and give you some feedback.
Okay.
Yeah, I think in production, whatever IP we provided for the API server for the etcd, it has to be either load balancer or class IP kind of thing. So, but the way in terms of the complexity, do you think this figure looks complex or the workflow looks complex? Because
yeah, the workload, because you have a CR, you have double CR. If we combine the nested etcd CR and EC cluster CR,
yeah,
in a way that's Chris just mentioned that we can combine it a bit.
Yeah, I understand. Because this is exactly what Chris was mentioning, right? So the way, if you really want to combine it, we have to, because we need to create a CR anyway, but where to specify where is the place to specify creating the CR? Yeah.
I want to clarify real quick. I'm actually not suggesting getting rid of the two CRs. I'm recommending still keeping the two CRs, just doing them independent. Your workflow here is nearly identical to what I'm saying. The implementation of it is, I think, what I was mentioning. Because the implementation would be the nested etcd controller being able to change internally what the manifests are that it's using, which it could just change from being deployments or a stateful set or what have you, like the built-in implementation. So stateful set and a service, and then instead of mounting those into it, mount a CR that it just kubectl applies to create the etcd CR. So like everything, this workflow that you have documented is exactly what I was saying.
Okay, so just I think then the difference is in implementation side is maybe make this, so let me think about it. So you are trying to avoid people to write, provider specific code. Is it what you're trying to achieve? So you want to make it
not me personally. What we have here would be exactly what I'm talking about from the support perspective. Being able to go through and say there's a couple changes that I would make, but those I'll talk about those in the comments. Where we have the nested control plane controller going and creating the nested etcd CR, and then it going and creating the other CR is exactly like what like declarative patterns typically does, and it's the same thing as this. The way that this is all set up would allow us to be able to swap out nested etcd CRs, or the implementation controller, at least for the nested etcd CR, the nested Kubernetes API server could be swapped, and the control plane or the controller manager could be swapped the same exact way and backed by any custom CRs that you wanted, because you're just kubectl applying behind the scenes. And then there's some tweaks, of course, that you're going to have to do to make sure that we report status back through to the original objects. And that's really that might be the provider logic that you're talking about that you would still have to do, and that is 100% fine in my opinion, because if you're going to be swapping these controllers out, you should have to do a little bit of work. It's not going to be just free.
Exactly. So what I mean, the provider things is that in the controller logic, we just provide two high-level interface, like exactly what we do in the VC Manager: create, delete, and you implement your own create logic, delete logic. So it's kind of you know what I'm saying. So
I do. I don't know if you need those interfaces, but yeah, you could. But that means that you're gonna have to recompile everything together. If you do it separately, you could just swap the controller implementation and not have to think about having everything in. Yeah.
I understand. Now you just want to do what do you want to do is you just instead of doing that way, you just create a CR and let that piece of controller handle it.
Yep. You write the controller logic. The CR is just the standard CR that is the nested etcd CR, and then you rewrite the controller implementation if you need to use a custom one. The inbuilt should be fine for people just playing with the project and getting off the ground.
Oh, you are saying that you want to swap the entire controller logic? I mean, let me think about it. So.
Yes, in answer to your question. Yeah, I'm saying that you could go through and say, instead of having to compile in a new implementation based on like create, update, delete, you could just re-implement a controller that listens for a nested etcd CR.
Who's going to deploy that controller? That's my point.
Cluster admin? I mean, in our implementation, it would be something like we would swap that out to, say, for instance, use the etcd cluster operator, if that's what we go with, or if we have another one that we're going to end up using, we would just go and write the controller for nested etcd instead of using the inbuilt. We would just flag it off, in essence. Say, I only want to use the nested KAS controller and the nested kube controller manager controllers. And then when the nested control plane controller creates the nested etcd CR, this custom controller kicks off, does the same exact logic, and we just have a standard, I'm going to call it an interface, but it's a standard interface that's implemented as the status fields on the etcd implementation, or the etcd CR. Super easy. We don't have to even think about anything then.
Exactly,
and I think this supports that.
I think that's exactly what this figure is trying to achieve, right? We will just, if it is provider code, all the control logic is skipped. We just create a CR, wait for the status, update status, done.
Yep. Yeah, I think that's perfect.
Yeah.
Because that makes it so it's easy to swap anything out. And if we needed to implement more, if you needed to re-implement the way that Kube API server works, super easy.
Exactly. Well, what exactly interface what I mean is we need to have an interface to grab the status. I mean, whatever CR, that CR need to have a status for us to query. That's all we need. If there is an arbitrary CR, there's no status we can query. This won't work.
Totally, 100% agree.
Yeah, that's exactly say because I was thinking, I was trying to make this, as strict. At least in the beginning, we want to make it strict. So that's a reason we want. If we want to say we support this etcd operator, but at least which means we agree that rows etcd CR has kind of the field that we need. If somebody have another etcd operator, but we cannot grab the status in our recognized way, this has to be hard coded, and you have to change the code.
No, 100% agree. Yeah, absolutely. And one of my comments that I'll put on this is I would actually say get rid of all of the provider logic and just create it as an inbuilt thing, and then make it so that you can flag them on and off. And then make it so that if somebody wants to build a custom one, it's not in tree for us, because then we don't have to maintain it. And that's just going to be like, we can't maintain the implementation for 3 different etcd providers behind the scenes, or it would be a waste of time for us, in my opinion, to do that, where we could go and build a single inbuilt in tree and then just have it so that you turn it off and you go implement the same controller, the same logic. And we just have docs that say, if you're going to re-implement etcd, because that's the only one that I can really imagine it re-implementing.
I want to be more friendly, but you want to be more formal. I agree with you.
the thought process there is like, if you look at what, because in essence, the way that I'm almost viewing this is if you look at the inbuilt way that all the cluster API providers work today, they use the KubeADM controller control plane provider, so KCP, and so KCP is in essence just using KubeADM under the hood, and it provides all of the hooks that you can change with KubeADM to any cluster API provider. And I want to treat this very similar to that, where while we have the nested control plane, and the nested control plane uses all of those 3 components, the bottom half of your diagram from 2 down should be able to be implemented very similar to the behind the scenes of the KCP. And it could almost be pulled away, and you don't have to use the nested control plane provider or the nested control plane controller if you didn't want to. Like, you could go and create the CRs for each one of those resources and deploy your own bespoke control planes, not orchestrated by something else, if you wanted. If that makes sense.
I totally agree. That makes a little bit, at least the cleaner, simpler, because what exactly did we propose is we define all the CRD. Basically, we define the interface. The interact workflow with the NCP controller, that is part we need to implement anyway, because that is a central place that control everything. But
the orchestration.
But underneath that, we just have we just define CRDs. And we have a default implementation for the CRDs. And if you want to plug in your controller, you just follow the same CRD. You just swap the controller to your own one. That's it. Is what you're saying?
Yeah. And exactly. Yeah. Super. It makes it really lightweight. It doesn't have a bunch of extra logic, and then people can customize it how they need.
I agree, because they need to make code change anyway. So this won't complicate their work and make the interface even simpler without the provider field.
Now, I have one more contentious thing. We do have 10 minutes left, but I have one more potentially contentious thing. The one thing that I'll add in as a comment here, and I'll document what I mean more in GitHub, but to kind of like open the conversation, we could almost, it just means that you're creating more CRs on your own. You could almost rip out the template. You could rip out the template and make it so that the standard default implementation using the KubeBuilder declarative patterns project for each one of those, the default CR, if it gets created, it can provision the default implementation, which is just the built-in, it works out of the box. You don't have to configure anything different. And you don't need the template then because the template, in essence, is already implemented in each one of the independent controllers.
So which template are you talking about? Are you talking about the
NCPT? Yeah.
The template of the NCP?
NCPT,
yeah, NCPT.
Okay. I understand. So yeah,
because how you have it implemented, if you scroll up a little bit, you have you do a bidirectional association of NCP and each one of the CRs. If you just basically make it so that you rely on the component having a reference back to an NCP, then we don't need the NCPT. It's just that out of the box, every single time somebody creates one of these things, you either need to create those 3 CRs or the controller goes and creates those 3 CRs. I'm not sure what the best path is there.
Yeah. That's exactly. So currently our thought is, NCP controller has to create those CRs because I don't like an idea is we need to have another step to create those CRs separately. That doesn't make too much sense to me in terms of the workflow.
We should support both. Where if you supply them and you have the references back already, it doesn't create them and it just like absorbs those.
Okay, if you think we need to support both, that's okay. That's NCP design program. For the underlying component perspective, all the requirement is we need to have a place to find out the rest of the components, which is NCP status. If we agree with that, who populated that, and as long as you have that, then that's okay. So the template, what I was thinking is, you can get rid of a template, but then you have to, somehow guarantee that the CR version that you provided is a valid version combination. So that's the whole part I was thinking. So are you going to do the validation in the NCP controller?
Tell me more what you mean by that. What do you, the version compatibility like of the components?
Yes, because in the NCP controller, you need to create a 3 CR, right? In the 3 CR, you can ignore all the field, but at least you need to provide the version. Which Kubernetes version you need to have, right? What if people were saying that the combination is a Kubernetes 1.18, but etcd is 2 point something? And these 2 things may not just work, not work at all. So we need to have a place to do the validation.
That makes a lot of sense. I would almost say that could just be in the NCP. And if you supplied into the NCP CR into the spec for that, you supplied a Kubernetes version and an etcd version, and then it uses the channels association within each one of those CRs to pull that specific object. Then the NKAS has to just implement a channel that is 118, and then the etcd has to implement the whatever version you're supplying. And then we can maintain a map for validation purposes of, does this control plane work with this etcd version? And then that's just something that's built into the controller.
Yeah, I think you can get rid of a template because in my understanding, template would be at a simplified version of each component. That's it. No more, because the rest of the thing you can use is default. People can just not specify. I will give you the default. The other is replica resource. We can just give the default one, but the version is the one that you have to provide. If you can somehow maintain the valid map somewhere, if you figure out either, I don't know, either there is a URL point to the right combination, or you build a logic somewhere in the NCP controller in memory, that's another topic. But I feel, my all concern is we have to do the validation, and the interface, we don't rely on that template at all, because if you look at our design, we just get rid of the template because we look at the actual object.
Right.
So that
and that's the right thing, and that's the right approach. I think like looking at the physical objects is going to give us the the proper status. And then if you wanted to, so it's because we're talking about defaults being the nested etcd CR has a default of the replica count. If you wanted to change those, being able to do what I said before, where you could supply the nested etcd CR, and then it just like absorbs the association or sets up the association in the NCP controller, then you could say, I want 5 replicas of etcd and 3 replicas of the controller manager and 3 replicas of the Kube API server. By supplying those CRs, they get configured with the NCP. Everything gets, in essence, it's very similar to the way that a replica set can get reassociated with a deployment if they're ever disconnected.
The whole problem is, so it'd be nice to have a declarative way in one place. You declare, so I understand, this loose decoupling, flexibility, but I don't. So if I'm an operator, if I cannot see all the replicas in one big picture, I mean, you know what I'm saying? So I want to look at one place. I know exactly how many replicas each component has. That's easier for us. Otherwise, I have to type 3 times to find out the replicas of all the components. So in other sense, so maybe that's the reason somehow I want to put a template somewhere there, because that gives you a place to specify exactly the information that we expose to this number of replicas somewhere. Anyway, if you get rid of the template, then you probably have to, in the NCP spec somewhere, you need to specify the replica count. If you
but then you have to supply it across each one of the components. I think there's 2 ways here. If you go the really abstract route that we're talking about, where each component implements its own fields,
I see.
And
so
then you could technically build a nested template controller that gives you that visibility that you're saying. Or there's other paths that we could do, like we could build, when we actually set up the the print columns, for example, on kubectl, we could apply a category that says this is a nested control plane component, and when you do kubectl get nested control planes, it lists off all those, and we can add in a print column that is the replicas, for example, if that's like attributes that we need to be able to share so that operators can see it. There's other ways that we could do that versus giving them a declarative CR up front that goes and does all of it.
Another way that we can do is actually we can just put the replica information in the status. So the whole thing is,
that's true.
Yeah, in the NCP controller, you need to watch row CR. If row CR change, just update your status. Then you have a centralized place to see all the changes. And the individual controller just respect rows CR changes to change the replica, which is kind of decoupled. But yeah, it's all. So I mean, we just have 2 design choices, right? Either we configure everything in a single place. That's one design choice. Then the NCP spec need to tell exactly what individual component look like in terms of the replica, resource, whatever, right? That's one way we do. The other way we do is we leave this out to all the controller. We only have a place to, I mean, the NCP is more like, the orchestrator, orchestrator workflow. That's it. We don't specify exactly declare status and let each individual component handle this. And we have status to report the results, because somehow, because maybe we want to we want to do something is like, for all the I think that's 2 ways we can do. I'm okay. So I think both have their advantages. I mean, the first one is more strict. I mean, is say I tell you you have X number of replicas, then your controller is, the configuration is overwritten, so no one can change it unless anyone want to change the replica. You have to change the NCP spec. That's the only entry point to change the entire class configuration. Another part is we don't do this. We allow each one to operate each controllers. I mean, each individual CRs, manually, kind of thing. I think both have their valid point. Maybe they have their use cases.
The one thing that I would say, the one way that I'm looking at this is I look at a template as being a one-way door. It'd be really hard to unwind that in the long run, versus if we go the other route where we go more flexible up front and then add on the abstraction layers later, like adding it, because you're right, a template will be really useful if we can add that component into it. But if we start with flexible and then add a template, then it's just an orchestration of the lower level objects. And then we have in both routes. So
yeah, I think as long as we agree that we have a central place to look at the picture, for example, we just leverage status, we are fine.
Yeah.
I mean, I'm fine because all the things I think should just work. It's just the operation kind of differences that provides. Because in the end, I don't think people will do such, I mean, very fine granularity customized for each CR in practice. I doubt it will be the case. More likely is they look the same.
maybe we'll see. We'll see what happens there. Cool. Okay, we are out of time. We're at 11 o'clock, so I'm gonna stop this recording. Thank you so much for taking us through this whole design doc. Everybody on the phone, please make sure you go and actually review the PR, and let's get feedback written up on there, and then we can start moving forward. And next week we will be canceled because of KubeCon. Hope everybody can actually attend.
I think in Chao, I think we can take Chris' comment about that service part. Let's make that more, dig a little bit more to see if you can move something into the nested API server controller to do the PKI thing, and move and just put exactly necessary part in the NCP controller. Is that okay? So instead of just build a service, which looks like is a little bit disjointed. I mean, from the workflow perspective, but we need to think about it more to see if that part can be optimized. Other than that,
and don't.
Yeah.
Go ahead. Yeah, I was gonna say, don't be afraid of potentially just using, like, if you go on the cluster API docs, there's a whole section on the PKI setup within the KCP implementation, and they just use a shared set of names. So like it's like the CA, for example, gets stored as a secret in the namespace called the cluster name -CA. And so you can always use those things to reference it. And so like, no matter what creates those components, you could always pull them from every other CR, for example. Like if you need the root CA from the full entire setup, etcd could go and grab that same exact secret. KAS could grab that same exact secret, and KCM could also go grab that same exact secret. Same with all the like admin kube configs. There's like standard paths within cluster API for all of those things to be stored, and we just want to use that same thing. So.
Okay.
Cool. Thank you so much, everybody. All right, I'm going to stop the recording, and then we'll resume this in. Actually, wait a second. So 3 weeks from now is also Thanksgiving, so we'll resume this in December.
Okay.
We should do some stuff async over GitHub, and then as we need to, we can always schedule an ad hoc meeting so we can go through this stuff as we move forward.
I think we need to have this proposal approved as soon as possible. Then maybe Chao can do some scaffolding code for this.
Please, yeah, that'd be great. Yeah. Awesome. Also on that note, Chao, I'm working on some pull requests for KubeBuilder. There's two things on the actual implementation as we get to it. We're looking at we want to be able to use the new V3 setup within KubeBuilder. So that's still alpha. It should be released end of next week-ish. We're going to be releasing a new version of controller runtime, 0.7. And then on top of that, we're also going to do, that'll be the new V3 plugins, which also gives us an inbuilt component config setup and a bunch of other cool ways of doing this. So, and then also the plan when we actually start to implement this, just to completely call this out, is we're going to try and use the V1 Alpha 4 APIs for cluster API instead of the V1 Alpha 3, so that we can kind of help spearhead driving that forward. But those are just extra call outs.
Okay.
Cool.
All right. Thank you.
All right. See y'all later.
Yeah. Bye-bye.
See you. Bye.